Maybe you've heard that XNAT is the leading open source imaging informatics platform. But what do you get when you start using XNAT? I'm going to guide you through a simple presentation, and we'll take a look at what's inside the box.
XNAT is a highly extensible web application that runs on an Apache Tomcat server. XNAT can support many kinds of data, but it was engineered for the unique challenges of managing imaging and clinical research data in one system. Most importantly, it allows you to store indexed research data and image files in the same system. XNAT comes with additional utilities for processing data, as well as support for automation with the XNAT event service. How's it organized? XNAT has a project-oriented data and permissions model. This means that project owners have complete control over who has access to their data and what they can do with it. With XNAT, you can store indexed, searchable experiment data in a Postgres database, as well as resource files in a file system. And XNAT has an extensible XML-based data model, which means that you can support nearly any kind of tabular data with a defined XNAT data type. At the core of XNAT is its API, which is used to access core XNAT services, such as uploading, downloading, removing data from your system, triggering data processing, or performing any number of other services. The API is accessible outside of the XNAT user interface, allowing scripted interactions and integrations with other applications. However, the API is tied to the user permission model, and this ensures the appropriate security for each action. How can you get data into XNAT? XNAT has built-in methods for uploading image session data by direct input from users or by acting as an SCP receiver on your network so that PACS and other DICOM devices can send data to it. XNAT also has built-in methods for importing large quantities of experiment data, as well as a customizable UI for manual data entry. To guard against inadvertent PHI entry, you can proof your imported image data in a pre-archive before you finalize storage in the archive. You can also set up automated anonymization methods in XNAT to prevent any PHI from being inadvertently imported into your research system. And optionally, you can find and remove burned-in PHI from your image data using pixel anonymization. Let's talk about security and access control. Permissions in XNAT are granted to users on a project-by-project basis. This means that project owners have discrete control over who has access to their data and what they can do with it. All project users can search and filter on stored data according to any number of criteria, and can share data into new projects and download data as well. A smaller number of project users can add, edit, or delete data, or invite fellow users to collaborate. Site administrators have access to robust user administration tools across all the projects on the site. XNAT uses Spring Security by default for local authentication and access control, but with additional plugins, you can use an LDAP server or OpenID for authentication as well. Advanced users can also use XNAT's API to generate an alias token to create a valid login session for their external applications. So what do we mean when we say that XNAT is extensible? XNAT's plugin architecture means that you can easily add features and functionality. Examples of plugins that you can install would add support for the container service, a PACS query tool, a powerful new image viewer that lets you draw and save ROIs, and authentication methods, and more. XNAT also allows you to add modular data processing capabilities, whether you're using the container service or the legacy XNAT pipeline engine. And advanced XNAT deployments allow you to add massive file stores, or connect to high-performance computing, or deploy multiple load-balanced front-end servers. The sky is really the limit. And this is really just the start of what you can find and do within this platform. Keep going to learn more.